How does a self-driving car work? How does it see? How does it anticipate and react? What are its advantages, limitations and main applications? An electric car unlike any other being tested at Amsterdam's Schiphol airport. It started using a smartphone. It can pick up and drop people at specified destinations, park and wirelessly recharge in special parking lots, all by itself.
The special thing about this car is that we can navigate and locate ourselves exclusively with cameras. The cameras are almost invisible, built into the wing mirrors and in the badge at the front. We can do lots of things, including locating the car in the car park. We recognize obstacles with these cameras.
So how does this car perceive its surroundings? Cameras and ultrasonic sensors ensure 360-degree coverage. Scientists from the European research project involved say the system can distinguish between vehicles and pedestrians.
Here we see the images relayed by the camera. Here, for example, is the camera directed to the right. From this camera we can reconstruct the scene in 3D and identify obstacles that we can then use in the car for navigation.
The car was even designed to understand the different movement patterns it perceives around it, so it can adapt its reactions in real time.
What we see here is basically the world as seen through the car's eyes. We see on the one hand the data of the stereo camera, which virtually tells the car where it can and can't go. Then, several times per second, our car evaluates hundreds of different driving maneuvers and chooses the best among these maneuvers.
For safe, accurate driving in parking lots where GPS signals are unreliable, the car creates its own localization map, mixing data from its cameras and sensors with information from a parking lot server, so the vehicle is always aware of its position.
If we want the vehicle to locate itself within its environment, we need to make connections between what the vehicle is seeing and 3D points stored in the map of the car park. These connections are marked as coloured lines. That's how you can then determine the exact position of the vehicle.
The car was designed to park and charge only in parking lots, but researchers dream of a future with automated cars an integral part of everyday transport. However, there are technical and legal challenges to overcome.
So currently the car is driving at low speeds, and in order to make it more attractive we have to increase the speed, but for that some technological challenges have to be tackled. One of them is improving the perception capability, but the other one is also the reasoning capability, so that the car can make good predictions about what the other traffic participants are doing.
Other issues that need to be addressed involve making the car as safe and accurate as possible with minimal infrastructure changes and keeping costs low for potential users. But the journey starts here.